Well, that was new. It's never done that before. Hello, geometry student. Welcome to a little geometry lesson on finding the midpoint of a segment. We're just going to kind of make this a short little video just about midpoint, and that's all there is to it. I'm going to do kind of one problem that'll be a little bit longer, not long, but a little bit longer, where I kind of go through some of the concepts at hand here, and then we'll do a couple, like maybe 2 or 3 practice problems that we can just knock out real quickly. Okay, so I'm going to start here by trying to share. Hopefully this works out okay. There we go. Okay, so I have a coordinate grid here, and if you want to take notes on your own, that's fine. You can do whatever you want. I don't know. I'm not there. I'm not watching you, but I have a coordinate plane set up here with a segment. This is segment AB. And the goal of this problem is to find the point that is directly in the middle of this segment. Okay, so like I said, we're going to kind of look at the concepts involved in this problem. And I'm just going to say, if we want to end up at the point that is right in the middle of this segment, it's going to be somewhere right around in here, right? But we want to find exactly where it is. Kind of think about if you were standing on point A and you wanted to walk directly to point B, but this diagonal road was closed and you weren't allowed to just walk straight from A to B. That would be the easy way. But instead, you have to walk to the right. Okay, so you're going to go to the right a while, and then you have to walk straight down. Well, let's look at how long each leg of that journey would be. So if you walk right and down, how far did you walk right? And we can just count. We can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that distance is 12. And then if we count down 1, 2, 3, 4, 5, 6, 7, 8, that distance is 8. So we go right 12 and down 8. Now let's think about some other ways that we could come up with those distances, like some other ways that we could figure out that top distance there was 12, besides just counting squares. So some other things we could do, since this is going left and right here, we're going to look at x coordinates from -5 to 7. So we can just kind of think about what's the distance from -5 to 7. And you might be able to just think of that and come up with 12. The distance from -5 to 7 is 12. Another way that some students prefer to think of it is just kind of don't worry about the negative. We call that absolute value. Just add 5 plus 7. Just do 5 plus 7 and you get 12. Another way you can think about it is to subtract 7 minus -5. And remember that when we subtract a negative, that's like adding. So 7 minus -5 means 7 plus 5, and that gives us that length of 12. Now to come up with that length of 8, instead of counting the squares, we're doing up and down now. So this is y coordinates. So we're going from 3 down to -5. So you can just think about what's that distance from 3 to -5, and you might be able to figure out that that's 8. Or again, you can just kind of ignore the negative here and say, what's 5 plus 3? That gives me 8. Or you could subtract 3 minus -5. That's 3 plus 5, which again gives me 8. Okay, now let's say that instead of walking all the way from A to B, you only want to go halfway from A to B. So it makes sense, if you want to only go halfway, that instead of going right 12, how far right would you go? You'd probably only go 6. So we'd go 1, 2, 3, 4, 5, 6, and we would stop there. So we would just go a distance of 6. And then instead of going down 8, we'd only go halfway down, and we go down 1, 2, 3, 4. Looky there. So we're only going down 4. And what do you know? We end up right back on the line, and that point is the exact midpoint. So that means that each side of this segment is congruent. So we can call that segment M if you want, or point M if you want to. The coordinates of that point, let's see, its x coordinate is 1 and its y coordinate is -1. So the coordinates of the midpoint are 1 and -1. Now you can see how we come up with this 1 here. If we start at point A, like if we start at -5 and go right 6, if you start at -5 and add 6, don't you end up at 1? And if you start at 3, if you start at a y value of 3 and go down 4, If you start at 3 and subtract 4, don't you end up at -1, right? So that makes sense there. Now, this is all fine and good. The problem being that every time I find the midpoint of a segment, I don't want to have to draw all of this out. This is kind of a pain. So it'd be nice if there was a nice, easier way to do this. And in fact, there is. I want you to notice here that the coordinates of this point M, let's start with the X coordinate. The X coordinate's 1. Look at these two X coordinates, -5 and 7. And I just want to point out that if you add those X coordinates and divide by 2, and that gives you +2/2, doesn't that give you 1 as an X coordinate? And then look at the Y coordinate as well. If you add 3 and -5, so 3 plus -5 and divide by 2, isn't that -2 divided by 2, which is -1? And do you know in math what you do know this? In math, when we add two numbers together and divide by 2, that's called the average, isn't it? So all we really need to know for midpoint is that the coordinates of the midpoint are the average of the coordinates of the endpoint. And that might be something that you want to write down. If you're taking notes there, that might be a good note to take. That the coordinates of the midpoint are the average of the coordinates of the endpoint. So that kind of makes intuitive sense a little bit, right? That the point right in the middle would be the average of the points on the end. So when we find midpoints, we don't have to go through all of this every time. For instance, let's say that I have segment, a segment whose endpoint is, let's say, K, whose coordinates are -3, -9, and the other endpoint is, let's call it P, and those coordinates are 7, -3. And our job is to find the midpoint of segment KP. When I say find the midpoint, I mean find the coordinates of the midpoint. Well, instead of drawing that out and figuring out how far right and down and what's half of that and all that stuff, I mean, that's good to understand. It's important that we understand that conceptually, but instead we can just do an average. So the average of the X coordinates, so I'm going to add my X coordinates together and divide by 2. So let's see, as an X coordinate goes, -3 plus 7 is 4. 4 divided by 2 is 2. And then for my Y coordinates, I'll add those together. So -9 plus -3 and divide that by 2. And if you just want to write this as -9 minus 3, that's fine. So that is -12 divided by 2, which is -6. Those are the coordinates of my midpoint. Okay, that's all there is to it. We can do one more over here. Let's say that I have point A, whose coordinates are 5, -2, and point B, whose coordinates are 8, let's say 8, 4. Okay, and we want to find the coordinates of the midpoint. Find M, which is the midpoint. Okay, again, we're just going to add up the coordinates and divide by 2. So we'll add up the X coordinates, that's 5 plus 8, divide by 2. Add up the Y coordinates, -2 plus 4, divide by 2. We're just doing an average, that's all there is to it. So 5 plus 8 is 13, 13 divided by 2, 6.5. -2 plus 4 is 2, 2 divided by 2, 1. There are the coordinates of my midpoint. Okay, so quick and easy, no big deal. All you need to learn from this is that idea that the coordinates of the midpoint are the average of the coordinates of the endpoint. Great, see you next time.